If we read the question, so this is what I want you to do. This is exercise 14H. 14H, your goal is to solve. I want you to read it. So when I say read, I mean like, it's not the find all solutions, but I want you to read this equation because they all mean something. And in this case here, you're really just saying sine of an angle is equal to half. Okay, and that's what I want you to understand. Sine in a unit circle, what does sine represent again? The y values. Theta is your angle. It's like where you are in the unit circle. So what they're trying to say is I want your y values. So that's just saying y values is equal to half around the unit circle. Now if you think about y values, you start from -1, which is the smallest y value you can have, all the way to the largest y value that you can have, which is 1. So logically, half has to be here. That's where half is. So if that's where y values are half, so where around the circle would you have to be? It'd only be in these two quadrants. Those are the only 2 points where your y values is equal to half. So what are they asking when they say find all solutions to the equation? They're just trying to say, well, if you started at an angle which is theta, starting at 0, so you're starting at 0, and then you're moving all the way around. You're all the way around, and that makes 2 pi. But you're going to 4 pi. So every time you go around, when do you reach a y value of half? When means like what angle? So angle is this. That's what you're looking for. So number of solutions that you're going to get. How many of these solutions as you're going, is it 30 degrees and then another one over here and then you go all the way around, it's now, I don't know, more than 360?
You're only going to get 4.
You only get 4, good. And that's what I'm trying to get you to think. So every time you read these equations, I don't want you to think of it as like how to do it. I want you to read it. What is it asking you to do? And it's just saying find the y values when it's equal to half and you're right. So in 2 revolutions, logically, yeah, there's 2 for every revolution. So if you go twice, it is true. You are going to get 4. Okay, and those 4 you can figure out. And the first thing you got to do is you say, well, this is why you have to learn your exact values. And I asked you to memorize that. Because you ask yourself now, well, what angle would you have to have sine of to get half? Sine of what will give you half? You can use the hand method or whatever it is. 30 degrees. 45 is root 2 on 2. This is the only one sine thing that has 1. Root of 1 over 2 gives you 1/2. Yeah? 30 degrees. Yes. Yes. Absolutely correct. And the only thing you got to work with now is not in degrees, got to work in radians. Whatever Renata just said is literally the logic to what you need to do. Okay, so think about it. This is what we just figured out. We just said we know the angle needs to be 30 degrees. We also know by symmetry properties, this means this also is 30 degrees. You know you started at 0. So your first answer, theta, which really in mathematically what you were meant to do is you say sine inverse of sine of what will give you half. And you figured it out. You said it had to be 30 degrees or equivalently pi on 6. Okay, that's what we know. We knew that to sine inverse both sides, theta will equal to sine inverse of half, meaning sine of what gave you half. And you guys told me 30 degrees. Okay, so we know the answer is 30. But the problem is there are infinite solutions. But in our case, there's only 4 solutions. Okay, so you have to figure it out. You're like, all right, well, it's equal to, and this is what Renata said, starting from 0, moving up, it's our first solution. We knew the first angle was 30 degrees. So 0, starting at 0, I added 30 degrees to finally get to my solution where I get half. Y value is half. So the first one is 0 plus 30 degrees. But remember, we're not trying to work with degrees. It's better to write it as radians because we're talking about the distance. So from 0 plus pi and 6. That's what we're saying here. So I'm going to write in red 0 plus pi and 6. Okay? That will get you your first solution. Then you go all the way over here. You know that's 30 degrees. So the angle had to be 180 take away 30. Will give you that same height. Now 180 take away 30 will give you 150 degrees, which is true. But we're not trying to work with theta. We're trying to work with radians because that's in radians. So 0 to 4 pi. So we've got to work in the radians, not degrees. So instead of saying 180 take away 30 degrees, we know that 180 degrees is equivalent to pi. And it's short by pi on 3. This is what you were doing in the last session where I'm trying to get you to work with sine of 7 pi on 6 or something like that. It's the same thing here. You're saying pi minus pi on 6. Pi is 180, take away 30 degrees. So there's my two solutions. From 0 to pi, these are the only times I'm going to get a y value of half. After, there's no point. All the way here, I get to 2 pi. Now from 2 pi, I need to keep going because I need to fill out 0 to 4 pi. I need to make 2 revolutions. So, starting at 2 pi, I move up a bit, and there we go. We get another solution. Because we get another solution, that's now 2 pi plus pi on 6. Or you can think of it as 360 degrees with an extra 30 to get there. And that's why Renato said it was 390 degrees. It's true. And then over here, that's an extra 180, subtract. Okay, so if I wrote out all my 4 solutions, I had 2 pi plus pi and 6. And over here, I know that's 3 pi minus pi and 6, because 3 pi and I'm short by it by pi and 6. And then finally I finish at 4 pi, so 2 revolutions. See, so my first revolution I had 0 degrees, add pi and 6. I had pi minus pi and 6, that's my first revolution. In my second go, I started at 2 pi, and I knew I just needed to go up by pi and 6 in the first quadrant. In the second quadrant, I was just short of 3 pi by pi and 6. That gives me, every one of these solutions should be the same as half. Okay, so what I'm trying to say there is, instead of saying, it's like saying sine of pi and 6 is half. Sine of pi minus pi and 6, this is what you were working with. Yeah, and then sine of 2 pi plus pi and 6, this is what I've been trying to work with you. Previously I said, like, how many holes are there? And I said, try to work out where you are in the unit circle, because I was trying to train you to do this. I was trying to get you to solve for the x-intercept. And that's what you're really trying to do right now. In our case, it's not the x-intercept. We're just trying to find when sine equals half. Soon you're then able to find the x-intercept. Okay? But that's the start. So every one of those should equal to half. And you're asking, well, what angles are they? In radians, our final angles were 0 plus pi and 6, which is pi and 6. We had pi minus pi and 6, which is 5 pi and 6. We have 2 pi plus pi and 6, which is 13 pi and 6. And we finally have 18 minus 1, which is 17 pi and 6. These are the angles starting from 0. So fitting into that domain that we asked, we said 0 to 4 pi, I need to know what angles will give me that half. So if I chucked in those numbers there, pi and 6, if I did sine of pi and 6, I should get half. If I subbed in 5 pi and 6, sine of 5 pi and 6, it should still give me half. If I did sine of 13 pi and 6, it should give me half, because I'm just going around the unit circle until I get half. Does that make sense? Yeah? And so that's the hardest part for a lot of students to see. It's the number of revolutions you do. And in my first year, it was so hard to teach for a lot of students to see that you're just moving around the unit circle. And I had to draw circle after circle. I was sort of like, that's 1 revolution, that's 2 revolution, that's 3 revolution. And you know, it's hard because in your textbooks, you're going to memorize each and every one of these regions. So if you go to your textbook, there are 9 rules to remember. It'll be pi minus this, 2 pi minus that. But that's hard to understand. But if you actually just figure it out as where you are in the unit circle, that's all you care about. You just want to know, is my x value, y value, negative, positive? That's all you want. Doesn't matter about the properties. So don't memorize that. Try to visualize it like this, and it makes a lot of sense. Okay, so we'll do another one. Yeah, just to get the feel. So that's the answer to your solutions. So when you say final solutions, sine inverse both sides to get theta by itself, sine inverse of half. Yes, it is 30 degrees, but there are multiple solutions. And according to your domain, these are the possible solutions. And we figured them all out. There's 4 of them. Okay? All right, let's try another one. Let's move on to, let's do example 18. I'm going to move this one across so we can work with it here. All right. Same thing. Read what it means. Okay, read the values, picture the unit circle, look at the domain, and then try to logically work with it. Okay, so here we go. Find 2 values of x. So in this case, they told us how many values there are. It says sine of x in radians, because that's 0 to 2 pi, so it's in radians. Sine of x means the y values of an angle x such that you get negative 0.3. Okay, so draw a unit circle. Draw a unit circle. And think, okay, I want my y values to be negative 0.3. See, logically, for it to be negative 0.3, we know y values are negative 1 to a maximum y value of 1. So 0.3, negative 0.3 has to be somewhere here. So let's say roughly here, negative 0.3. That's my y value. So where around the unit circle will I have to be to get a y value of negative 0.3? These are the only two possible points where the y value, or the y coordinate, would be negative 0.3. Negative, well, my God. Here we go. Okay, so that's the only two coordinates, meaning you're only in these two quadrants. Those are the only two times where you're going to have a y value of negative 0.3. Now it says find x. In our case, we don't know the exact value for 0.3. Okay, the other ones were easy. Pi 6, pi 4, pi 3, pi 2, we know. We don't know what 0.3 is. This is where your calculator comes in. But what they're trying to teach you is to solve. So logically, you're saying, oh, well, I just need, if this is starting at 0 degrees, or 0 radians, 0, I go all the way here, that's pi. It's pi plus whatever this distance is. I don't know what that distance is, but I can use a calculator to figure that out. So how do I figure it out? So I got sine of x equals to negative 0.3. I want to find x. I do the inverse of both sides. So I'm like, all right, well, sine of x is sine inverse, both sides. That now gives me x is equal to sine inverse of negative 0.3. Now this is where you can use your calculator. Type in sine inverse of negative 0.3. What does that tell you? When you say sine inverse of negative 0.3, it just tells you the distance or the angle. So once you know the angle, the beauty to it is you know it's just pi plus that extra angle. Whereas over here, it'll be 2 pi minus that leftover angle. See, logically, that's what you're doing. So whatever this answer is, you're going to have, the solutions are, the only two coordinates you will have is that distance, which you can figure out from here. That distance will be pi plus whatever that extra distance is. Here, you're moving around the unit circle and you reach 2 pi, but if you just minus that distance, you got that equivalent sine value. So this is what we don't know. Whereas previously, we did know. See over here, sine inverse of half, we knew. That was an exact value. We knew that it was 30 degrees or pi 6. So that's why I could just say 30, 0 plus 30, or 180 take away 30. But because you don't know what it is, this is where you use your calculator to figure it out. So my answers would be pi plus whatever sine inverse of negative 0.3 is, which I don't know. Anyone got a calculator? Just quickly solve that for me. What's sine inverse of negative 0.3? Negative 17.5? 45. Did you guys make sure it's in radians? Make sure it's in radians. So remember, if you're working with radian values, make sure you use radian values. If it's degrees, use degrees. Okay, negative. So this value here is negative 0.309. Is that right? Yeah? So that then in this case here, that's my radian value. 304. All right. Whatever that value is, yeah? So that just means pi, which is about 3.14, plus that extra distance. And this is 2 pi minus that extra distance. Type in your calculator and get your answer. But what I'm trying to get you to do is visualize where you are in the unit circle. Okay? Let's do another one with exact values so that you feel a bit more confident with these. Let's try these ones. Okay? Now, pay attention. 0 to 360, meaning the angle now is not in radians, it's in degrees. So you want the equivalent y value for degrees. Okay? Same thing. Let's try A. Same thing. Cos of an angle in degrees is equal to root 3 on 2. Let's draw a unit circle. Now you ask yourself, cos means the x values. Theta is the angle. We're trying to work out which angles will give you a positive root 3 on 2. So x value is positive. The only time x is going to be positive is around here, which is 30 degrees. Okay, so I know it's going to be here. And the only time around the unit circle that I would get an x value of root 3 on 2, see, root 3 on 2 is somewhere between here and here. It's larger than 1.5. It's just a bit more. So that means I've got these two quadrants. These are the 2 points that I'm looking at. So now let's work with the degrees. We're starting off at, they told us 0 degrees to 360. So starting at 0, you already figured out, you already did theta will equal to cos inverse of root 3 on 2. You knew this value is equal to 30 degrees. So you know that from here to get there, it's about 30, that's 30 degrees. To get a root 3 on 2 for the x value, it has to be 30 degrees. That's why you had to learn the exact values. So from here, 0, moving to the first solution, it's 0 plus 30 degrees. Then the next solution is you're moving all the way around the unit circle and you're like, well, none of it hits my solution so far up until you reach here. But here, if that's 30 degrees there, that's short of 360 by 30 degrees. Now I've drawn it badly, but in terms of understanding the concept, I'm short of 360 degrees. If that's full revolution is 360, then I'm just short by 30 degrees. So you'd say 360 minus 30. And these are the same angles where I will get the same x value as root 3 on 2. Is that a question? No? No? Okay. So that now gives you a final answer of 30 degrees and 330. So that means if you put in cos of 30 degrees and you did cos of 330, it should be the same value as root 3 on 2. That's what you're working for. Because remember, you're just looking for the x values. And you already know what angle it must be, so you're just working around the unit circles from 0 to 360. Those are the only 2 angles that will give you the same x value.
Question. How
Yep.
do you know when you're going to answer if degrees or
Based on the perimeter or domain. So if they tell you, like this is from 0 to 360, so you know it's degrees. Whereas over here, that's radians. See, the first one's in radians, the second one's in degrees. Yeah, so it has x degrees, 0 degrees. And same thing with the first question, theta is in radians. Yeah, so they'll tell you if it's in radians, it's in radians. If it's in degrees, it's in degrees. And it matters how you answer them. How do we feel with those? Yeah, I want you to start off with those questions. I still got one more example to do, but I think we'll leave that last. We'll do these ones first. Okay, so I'm going to get you to do these questions. Let's get you these questions. What I want you to do, remember you're trying to solve it, trying to solve the equation. This one's you're just balancing it, try to find theta by itself. But I want you to do 1, 2, and 3 just for this lesson, and then we'll work towards where you have the other ones where you have 2 theta and whatnot. But 1, 2, and 3, if you like, 4 might be easier to work with than 2. 2 is a bit weird. Okay, just because you got 0.3, you have to use a calculator. If you like, I prefer you working with 1, 3, and 4 to start off with. 2, you can go back. Yeah, that way you don't need to use a calculator. Here, you can do all these without a calculator. You can work out with what I was doing with you. Yeah, so 1, 3, and 4, start by learning how to find those intersections. Okay, and then we'll work with what happens when you have a dilation. But for now, let's work with that 1, 3, and 4. 1, 3, and 4. Let's get our heads around how to solve. And if you guys learn that well, then I've done much better than my first year teaching this. But so far, looking good. So far, looking good.